Hi, in this video, just we are going to see about the cylindrical beam having this distributed force and bending moment. So, as you can see in the problem specification, so here it is fixed. One end is fixed, another end is another before the end is like constrained in y and z direction, having this 2 point loads like with respect to 30 kilonewton and 60 kilonewton. This 15 kilonewton per meter is it's a distributed force. So we will see in ANSYS student. So in ANSYS student software. So here just I'm taking a structural steel. I made it a cylindrical beam. Its contact region it's by default. So let's see while doing this mesh. This default is minimum element size. Let's select 200 mm. Just mesh. So it's quietly tetrahedral mesh. So in the analysis settings, this kind of multiple loading problems cannot be solved in one single step. So we will take two steps and each step having 5 seconds interval. So this is step number 2. Make it 10 seconds. So now we are going to insert the boundary conditions. So as specified here. So click on fix support. This phase, and for moment there is a option called, if I click on static structural, there is a called moment. Take all phases and it should be in minus z direction or z direction. So it's almost 30 kilonewton. As your preference, you can change the units to meter. Then we insert a line pressure like a distributed force. There is an option in mechanical like I should insert as a line pressure. So I'll select this with respect to this end, like as you can specify in this from here to here. So then apply, then you can take more components in negative y direction. So now we are going to take about this point pressure. So point force, like select force, select this line. So here it is acting minus 30 kilonewton. Here it is acting 60 kilonewton. Then select force 2. So here it's 60 kilonewton, so 60,000 newton. If you want in inclination, it's 60 degrees, so you need to insert in here. It will take the normal yz direction, like vector potential y and z. So for this case, I'm taking only in negative y direction. So this is about the modeling. So I assigned analysis settings in two steps. So I take the moment, line pressure. I assign all boundaries of boundary conditions and loads and forces. If you control and hold the control, and if you click all the boundary conditions, you can verify whether you assign the all boundary conditions are correct or not. So you can validate. So then right click and solve. So we go in solution information. You can see the number of computations going to appear and how many iterations is going to take for solve this problem, and where it is at what iteration will get converged, solution get converged. So now it's gets solved. It's almost like it's take 24 seconds. So just I will evaluate a result output post processing in some physical entities. So I'm taking normal deformation stress. So which is strain energy. If you want to calculate the reaction forces at that these supports, so there is an option you can drag the into fixed support into solution to the force reaction. Same wise you can calculate with respect to, so sorry being here we are not assigned that this degrees of freedom, like this boundary condition. So now we are going to assign. So let's take displacement. So like here you can see only z direction is free, x and y is 0. If you take the displacement, you can drag to a solution, then you can get force reaction to respect to displacement and fixed support. So now we can solve it. So now it is taken. Now we solved respect to, you can better visualization, go to result. There is a called edges no wireframe. So it's almost zero point 0.5 meter. It's beyond expectations. It's like it's go to fracture strength or it's in a plasticity region. Same you can see deformation stresses. Yeah, it's almost 148 MPa, so it's quite high. Same principal stresses. So better you can go. It's quite higher stresses. Shear elastic strain. So next see the reaction forces. You can see the value here where it is x and y z axis. What is the total reaction force acting on this point? Same as well as here. And the displacement support. What is the total in x, y, and z direction? What is the maximum over time? This is the minimum over time. So yeah, this is the one case. It's a textbook problem how we can solve in ANSYS student. So how we can validate means like if your ultimate strength is cross below the yield strength, below the equivalent stress, then this design is safe. If it is crosses the yield strength, means design is broken, means it's under fracture strength. Yeah, thank you.